Hi guys, my name is Patrick, but you can call me 26. And what we're going to do today is we're going to talk about SwiftData and concurrency, right? Now, concurrency is just a fancy word about, it talks about how multiple tasks are executed, right? So if you have multiple tasks to do, how they're going to be executed. Now, when it comes to concurrency and SwiftData, this is particularly pertinent because SwiftData, if you have a large amount of operations involving SwiftData, it can lead to unresponsive UI because SwiftData is primarily handled on the main thread, right? And also, it can lead to data corruption. However, there's some stuff that SwiftData does in the background to try and make sure that you cannot corrupt data, right? Now, the thing with data corruption is, imagine if you are writing you try to write and update data at the same time, right? So you're trying to save it to the disk and also update it at the same time. This can lead to data corruption, right? So Swift has some methods that it does. SwiftData in particular has some methods that it does that try and stop you from corrupting data. We are going to look at how you can handle the matter of unresponsive UI and talk about a little bit about how data corruption is stopped, right? So let's get into it. Before we get to today's business, you could have a look at my course. That is the e-commerce full stack application. And what we build is iStore. And iStore, we build the front end and the back end. And iStore does use SwiftData. We use SwiftData in persisting our cart. So whenever you close the app, we save the contents of what you want to get into a cart. And in this cart, which also has a map, you can pick the location like so and do that. And this is persisted using SwiftData. And also among our carts, we have favorites, right? So we have our favorites here, and you could save the favorites, and the favorites are products that you like that you would want to maybe go back and later on buy. And this also uses SwiftData to save our particular favorites, right? So we do that. And also on top of it, we figure out how we can work with the observable macro when you're dealing with SwiftData. So all these are projects that we actually implement in this application. If you'd like to see the complete project, have a look at the link in the description. If you're going to see the 26-hour project in its entirety plus the source code. If you would like to see the first 12 hours of the project, they're available on my page on this channel, right? So have a look at that. Now let's get to the business. In particular, let us look at the problems that are caused by a lot of SwiftData operations that lead to freezing the UI, right? This is because the UI and both SwiftData are both done on the main thread, right? So let's have a look at the problem in question. So if we run this app, and we've been using this app for a number of to show a number of things, right? So if we run this app, it's taking a second, and basically what this app does is when you hit the button in the principal area, it's going to create random names of 100,000 footballers and 100,000 random football teams. If you hit the pencil, it's going to update the football teams that the footballers are on, and if you hit the trash can, it's going to delete them, right? So it does take a bit of time, and when we use this app to measure the times that these operations are done in SwiftData, right? So the code is available, and the code is exactly like the previous iterations, right? So we hit this, and you see already the UI is unresponsive. The plus button freezes up, right? So this is because we are generating them, right? So after we generate the 100,000 footballers, now it's available again, and it tells us the time. It took 5.456 operations, right, to get this done, right? So that is the case, right? And if we do the same, if we try and update them, right? So you see we can interact with the list, but when we hit the update, and we try, it freezes up on us, right? So we can't do this, right? It has to finish first, and then we can improve on it, right? This is because all this is done on the main thread, right? So how would we know this, right? So let's get rid of this and give it a second. Okay, we have deleted them, right? So let's give ourselves a bit more real estate. And what we could do is we could come to here in the for loop, we could put a breakpoint, and we could run it so that we can confirm that this is actually happening on this for loop here. What does it do? Okay, this is the trash can. Let's not do it on that. Let's do it on the generation. Where are they being generated? On the plus, right? So here, right? So for this for loop, we're creating 100,000. If we put it here and we run this, we're going to see that when we're actually creating the users, that it happens on the main thread. And you can confirm this by putting a breakpoint on the for loop, right, where we're creating all the users, right? So we hit this, and it's going to freeze, and immediately we're going to go to this particular section, right? And in this section, you're going to find that the thread in question is going to be, you can see here, com.apple.main thread serial, right? So you're doing it on a main serial thread, right? And the question becomes, can we do it in the background thread? Let me show you how. Now, what we want to do next is we would like to push the creation of the particular footballers onto the background thread, right? Now, how we do that is we create a function, and this function is just going to insert the footballers into the background thread, right? It's going to create the footballers, and what we want now is to figure out how we can push them to the background thread, and that can be done in the button where they're being created. I believe it's this one with the plus sign. And what we want to do is we want to wrap it in a task. So let's just come here and we say something like task, like so. And then come here, do this, and cut this, put it in the task. Because, and remember this function is asynchronous, right? So that's why we're putting it in the task here. And the next thing we want to do is, instead of doing this like so, what we'd like to do is we would like to call the function, so we can just say await insert, like so, right? Is we need to explicitly tell it that we will be operating on the background thread, right? We need to explicitly tell it that it's operating on the background thread, and for that we could just say task.detached, like so, and we want to say dot background, right? So we want background like so, right? Now when we test it, I think we need to hit that priority background, right? Now when we test it and then run this, we should get what we're looking for, right? So we hit this and it's taking its sweet time. Okay, I hadn't actually pressed it. And I don't know why it's taking its sweet time. And you see now, okay, fine. We come here and we are not on the serial, we are not on a serial thread, but we are now on a concurrent thread, right? Now I'll explain what a serial and a concurrent thread are, right? A serial thread, serial just means that they happen in sequence, right? So in serial, like they follow each other, right? And a concurrent means that if things are concurrent, they happen at the same time. Like these two threads, like the main thread and the concurrent thread are happening at the same time, right? So you see this thread in particular is concurrent. The one that this insert is being called on is different from the main thread, right? But it's happening at the same time, right? Now, I need to explain why SwiftData doesn't like concurrent issues, right? Now, think of all the things that you can do here. We can insert, we can update, and we can delete, right? So everything that you do to an object should happen concurrently, right? You should be able to insert and then update and then delete, right? If these three things could be called and they happen in an order that is not concurrent, is not serial, does not follow each other, right? We might find a situation where you're trying to update something that has already been deleted, right? So the order of operations has to be kept, right? So it needs to happen serially, right? As opposed to concurrently, right? We can talk about model actors, right? Now, model actors work on a serial thread, which is what SwiftData likes, right? Which ensures that there is no situation where you might corrupt the data, right? So that's what we want to talk about, our model actor, right? Now, one thing model actor can help us is the case of the unresponsive UI by enabling us to do background data, but not doing background data on a concurrent thread, right? Like you can see here, a concurrent thread means that our data can be accessed in a way that can lead to its corruption, right? Like you might try to delete something that is no longer there, right? We want to make sure that it only works on a serial thread, right? So what we want to do is we need to move it from the main thread. And remember, the main thread, which it was initially, is a serial thread. We need to also move it, instead of to this concurrent thread, we need to move it to a serial thread so that our data cannot be compromised by our actions. The next thing we need to do is we would like to have let's come to model. And what we want to do is we want to create our model actor, right? Now, model actor is created by you have to put model actor on it, like so. So you put the actual macro model actor there. And here is the information. We are going to create a background actor. And here we just create the insert functionality that puts the 100,000 particular footballers. And yeah, we save it right on the main thread, right? So what we want to do is we next come back to content, the content view. And here, what we need to do is we need to provide it to a container. So you could come here and instead of doing this, let's just check that again. Okay, we do save it, right? So we save all the 100,000, right? So what we could do is we could also get rid of this, right? So we could come here, comment that out, maybe give ourselves a bit more real estate. And after that, what we want to do is we want to put it on the background, right? So we can create it on the background so that the UI can be responsive. And that means that we can just come and do this, right? Detached is going to be background, and then we put the background actor with the model container, and we need the container. And this container is just going to be model container.container, like so. Let's put it here, like so. So we put the model container, pass it here into the background. It's going to stop complaining, and then we await background insert, right? So if we do that, it is going to be, in theory, it's going to be, This is how we're supposed to do it, right? So that it can be responsive. So let's just stop it and run it. And then you're going to see how responsive it is, right? So we're going to be able to interact as you're creating, right? So now if we hit plus, you see we have hit plus and it's still sort of accessible, right? We can still, it doesn't gray out, it doesn't freeze over, right? We can still do this, and our footballers are being created, right? Take a bit of time before you see them, but they are being created, rest assured. The thing you should note is that you can set the task detached, where we're setting the priority. We give it a background priority, which means that it's the lowest priority that is available. The highest is usually user initiated, high, medium, low, utility, and then the final one is background, right? So when you put in the background thread, it's going to take a lot longer. And in our case, it took a very, very long time to create the 100,000 footballers, right? But the advantage is that the UI is still going to be very, what's it called? It's going to be very, very responsive, right? Now, when we want to ensure that it is happening on a serial thread, right, rather than concurrent, where we should create it, we could come here and we set in the model actor, we set the breakpoint on the model actor where we have here. And what we could do next is just stop it, run it, and then maybe delete the footballers and then try run it again. And then we're going to see that it's working not on the concurrent, but on the serial actor, right? So that's it. Let's just have a look at that. Let's just hit that. And this is going to delete all the footballers. Give it a second. Okay, that's done. Hit plus. It's going to create. Okay, not going to create, right? So yeah, so we come here, we're pulled in, and you see that the queue that we're on is on the serial thread, right? So this is the background actor trying to insert, right? So if you check here, you find that we're actually operating on the serial thread on a different thread from the main thread, right? So we're not doing it on the main thread. We're doing it on a thread different from the main thread, but it's a serial thread rather than a concurrent thread, right? So as much as possible, we should ensure that our SwiftData stuff happens on a serial thread to stop data corruption, right? So that is a high level overview of concurrency and why we would always want to make sure that SwiftData always happens on a serial thread rather than a concurrent thread, because of the possibility of data corruption.